Before we get started, a quick disclaimer. Everything in this video is for educational purposes only. Do not use these techniques on real websites, networks, apps, accounts, or devices unless you have explicit written permission. With that out of the way, let's get on with the video. Hello and welcome back. So this is a continuation from the introduction I did before, and in this video we're going to continue the cybersecurity learning journey by looking at SQL injection. Specifically, I'm working through a PortSwigger Web Security Academy lab about retrieving hidden data that you can see on the screen. This one's interesting because on the surface it looks just like a normal shopping website. Click a category, you can see products, simple enough. But behind the scenes, that category is being used to build a database query. And if the application is vulnerable, we can change that query, as we said before in the last video. Not by hacking the database directly, actually just by changing part of the URL. So in this lab, we have a shopping application with product categories. If I click a category like accessories, the URL ends with something like $category equals accessories. That part at the end there is called a query string. So the application takes the category value and uses it to ask the database for products in that category. So the lab explains that the SQL query might look something like this. Now, when I first saw this, my immediate thought was, how would I know about the released equals 1 bit? Because that isn't shown in the URL. The answer is, I wouldn't know that. I wouldn't know that detail from looking at the page anyway. So the explanation was basically showing us what could be happening behind the scenes. In real testing, you're often making careful guesses based on how the application behaves, but we're lucky we've been given this information. So let's break the SQL query down. It's basically saying select everything from the products table where the category is accessories and the product's been released. The released equals 1 part probably means only released products should be shown. So if there are hidden or unreleased products, they might have released equals 0. Normally, the site would not show those. But if the application is vulnerable to SQL injection, we can interfere with the query. So the first payload is going to be this. Category equals accessories, single quote, dash dash. So what this does is add a quote and then an SQL comment. So the SQL query becomes something like this. Select all from products where category equals accessories, dash dash, and release equals 1. That double dash starts a comment in SQL. That means the database will ignore everything that comes after that. So the and release equals 1 part no longer matters. The query only checks for products in the accessories category. And in the lab, if I do that, it reveals a hidden product called Cheshire Cat Grin, which is a very PortSwigger product name. And honestly, cybersecurity labs have better product catalogs than most real shops. I mean, look at that, 6-pack beer belt, I'll have one of them. And then we can go further. This time the payload is going to be category equals accessories, single quote, plus or plus 1 equals 1 dash dash. So that changes the SQL query to something like this. So yeah, the important part here is or 1 equals 1. And 1 equals 1 is always true. So now the query says, give me products where the category is accessories or where 1 equals 1. And because 1 always equals 1, and unless there's some weird place that it doesn't, that condition will match everything. So then the comment removes the last part of the query. So now we're no longer just getting accessories. We're getting everything. As you saw at the top, that completes the lab. Solved. Marvelous. There's also an important warning that it gave in the explanation for SQL injection. So even though or 1 equals 1 seems harmless in this example, it can actually be dangerous. Some applications use the same input in more than one database query. So if that condition ended up in an update or a delete query, it could cause accidental data loss. So this is why I'm only doing this inside a legal training environment. Do not test this on real websites unless you have explicit permission. Stick to labs, deliberately vulnerable apps, or your own systems. Right, this is Editor Brian. I had to come rushing back into the lab because I realized that I've forgotten something, or forgotten to show you something. So we've seen SQL injection being used in a URL to reveal hidden products. But what happens if that same kind of vulnerability appears somewhere a little more sensitive, like a login form? So in this lab, we're back on the familiar vulnerable shop website. Ignore the fact that I've already solved this one, okay? But this time we're going to click on the My Account link, which takes us to a login page. So at first glance, it looks completely normal. We've got a username field and a password field and a login button. So the application is probably doing something behind the scenes, like checking whether the username and password match a user in the database. We can have a look at that by Dave and password. And of course it says invalid username or password. So a simple version of that SQL query might look something like this. Select all from users where username equals Dave and password equals password. So it's saying find me a user where the username is Dave and the password is password. Nice and simple. But if that application is just taking whatever we type into the username box and stitching it directly into the SQL query, that is where things can go very wrong. Because we're not limited to typing a normal username. We can try putting SQL into the username field instead. So because we're apparently going straight for chaos today, let's try getting access to the administrator account. So in the username field, we're going to type in administrator, single quote, dash dash. And then for the password, it doesn't matter, whatever. Because if this works, the password check is about to be completely ignored. So the query could end up looking something like this. Select all from users where username equals administrator, dash dash, and password equals whatever. There's our old friend, the double dash. It tells the SQL that the rest of that line is a comment, and so the part where it says and password equals whatever gets ignored completely. Which means the database is now only really checking select all from users where username equals administrator. So instead of asking, is this the administrator and does the password match? It's asking, is this the administrator? Yep, it is. When we hit login, oof, there we go, we're in. That's the administrator account. We've bypassed the login and ended up on the administrator page. That's a much bigger oh no moment than just revealing a few hidden products, isn't it? Because this shows why SQL injection can be so serious. It's not just about making a shop show items that it was hiding. If the same kind of vulnerability exists in authentication, it could allow someone to bypass login checks completely. Obviously, this is a deliberately vulnerable training lab, and it's exactly the kind of thing you should only test in legal authorized environments like PortSwigger Web Academy or intentionally vulnerable apps. Internationally vulnerable apps? They could be, you never know. Or do it on your own systems. But that's a useful moment for me. It made SQL injection feel less like some mysterious hacker magic and more like a very specific problem. User input being trusted too much, then accidentally becoming part of a database command. Anyway, just wanted to share that with you. Back to the other Brian to see you out of the video. So, there we go. That's an SQL injection, a simple one. The big takeaway for me is that the SQL injection is about changing the logic of a database query. The URL looks normal, the category looks harmless, but because the application trusted that input far too much, we were able to change what the database returned. So next video, I'll be continuing through more of PortSwigger Web Security Academy labs and more of the SQL stuff and documenting what I learn as I go. If you're also learning cybersecurity from scratch, hopefully this helps make that SQL injection thing feel a little bit less mysterious. So we'll be going on to slightly more detail of more stuff for SQL injection in the next video. And also we'll end up talking about how we can negate that, how we can code around and stop it from being a problem. But if you liked it, please hit the like button, comment, subscribe. Any questions, please put them in the comments and I will try to answer anything I can. If there's anything that's not clear, also put it in the comments and I will try my best to explain it. Because that's the only way that I'm going to learn and I know that I've got things right, is if I can explain it to someone, or if I've missed something here, then that could mean that I've got a bit of a gap in my own knowledge. So please do let me know. But thank you very much for watching. Until the next time, until the next video, catch you later. Bye-bye.